Right, section 4 is about the laws of sines and cosines. So those are two different things. First we're going to look at the law of sines, then we'll look at the law of cosines and some examples to go with each. So first off, we have the law of sines. Now this works for any triangle. It does not have to be a right triangle. It can just be any old triangle. We would label it, all of the corners, all of our angles will be capital letters. So capital A, capital B, and capital C. So this is triangle ABC. Their sides will be right across from those angles. So across from angle big A is side little a. Across from angle capital C is lowercase c. And across from angle uppercase B is a lowercase b. And again, those are the sides. Now you can write the law of sines one of two ways. You can either put all the sides on top and you make essentially a couple different ratios. A over sine A equals B over sine B equals C over sine C. Now you don't need all of these in here. So what I'm going to do is show you that you can just block one piece out. So we can say A over sine A equals C over sine C. I can block out this one and just use these two. I can block out these two, or just use these two. Okay, you don't need to have all three pieces in here, but all three of them are true if you put them all together. So we can use just one chunk of this or one piece of this at a time as we're solving out our equations. Now you don't have to write the sides on top, you can write them with the sine pieces on top. You just have to stay consistent. So sine A over little a equals sine B over little b equals sine C over little c. You can't all of a sudden put the sine of C down here and little c up here without switching these ones too. Okay, then it wouldn't be a correct ratio. But essentially law of sines is just a ratio saying the sine of an angle to the side that it goes with is going to be the same ratio as the sine of another angle with the side that it corresponds to. So let's see how this works in a couple of our examples. So we need to solve the triangle below. Now solving a triangle just means solving for each part, finding out what each thing is. Now we know that a triangle is going to have 180 degrees. So if this is 38 and this is 70, we would just do 180 minus 70 minus 38 and get 72. So we've already found one piece of this. We found that this is 72 degrees. Now we need to find out our other sides here. We know that this one is 6 meters, but we don't know how long J is or K. So we just plug it into our law of sines, and we don't need to use all of the pieces. We can just use like two at a time. We'd say the sine of 38 over 6, and these match because 38 here matches with its side 6 over here. So sine of 38 over 6 equals the sine of 70 over J. 70 and J match up. How do we solve proportions? We just cross multiply. So now it says 6 times the sine of 60 equals J times the sine of 38. Now if we wanted to get J all alone, we would divide both sides by the sine of 38. Do that over here as well. So now we'd have J equals 6 times sine 70 divided by sine 38. These two cancel out on this side. Now, if you're very careful, you can just plug that into your calculator, and it's going to look something like this. In parentheses for the top, 6 times the sine of 70. Oops, I missed my sine button. Sine 70. And parentheses. This is now the numerator part. 6 times sine 70 on top, divided by the sine of 38 on bottom. So it's this divided by this. In the end, we get 9.157 something going on there. So we can just say then J equals, we'll round it up to 9.2, and we are in meters. So J is going to be 9.2 meters, as we found on our calculator. I'm just going to write that in here, 9.2 m. Now we need to find our last piece, K. We set up the ratio, just like before, sine of 38 to 6 is the same as the sine of 72 to k. These two match, these two match. They're just right across from each other. Cross multiply. When we do that, we now get 6 times the sine of 72 equals k times the sine of 38. Like before, divide both sides by the sine of 38 divided by sine 38. These two will cross out, so we have k alone. So again, you can just plug it into your calculator, put a parentheses, so you keep the numerator all together. 6 times the sine, I already forgot what it was, 72 and 38. Sine of 72, oops, I missed my 7. Let's go back, punch that in. Divided by the sine of 38. And so that's going to give us 9.268 something something. We'll round that up to 9.3. So we could say K is going to be 9.3 meters. And now we've solved the triangle. We know every single part of it. Even though we only started with 2 angles and 1 side, we're able to figure out all the other pieces just using trigonometry. Find S and T. Now these are the angles. This angle S and this angle T. So when we've set this up, we'll use our law of sines again. The sine of 53, this one, matches up with 5. So the sine of S matches up with 5.26, this side over here. So like before, we'll just cross multiply. That's going to leave us with 5.26 times the sine of 53 equals 5 times the sine of S. Now this one's going to be a little trickier. We've got to get rid of that 5, so divide both sides by 5. After we do that, though, that really only gets rid of that part. We need S all the way alone, not the sine of S. So to get rid of a sine, we have to take that inverse sine on both sides. So the inverse sine, or sine inverse, of all of this. So we could do this first and then take the sine inverse of it. By the way, that and that will cancel, so we have S alone. Or, again, on your calculator, just being very careful on how you type things in, hit that yellow shift button, hit sine, so we know that we're working with our inverse sine function. Then just type everything in together as your numerator and denominator. Numerator was 5.26 times sine 53. So 5.26 times the sine of 53. I have this and this parentheses for my numerator divided by our denominator was 5. Closes that set of parentheses, because now that tells me this is everything inside of here is what we're doing the sine inverse of. So when I hit enter then, or execute, it gives me 57.157. So we can just round that, because we're dealing with an angle, we'll just call it 57 degrees. So we figured this one out as 57 degrees. Now, instead of trying to do some other crazy work, we know 2 of the angles of a triangle, and we know that they have to add up to 180, so we just simply do 180 minus 53 minus 57, and we get 70. So we've solved for all of the angles of our triangle. If we wanted to solve for this last side, we could use law of sines yet again, and we could figure it out pretty quick. Law of cosines. Law of cosines is going to be a little bit different from the law of sines. It still uses triangle A, B, C, and of course all the sides across from them are the same. A is across from A, B across from B, C across from C. But it says if you take your sides, A squared plus B squared minus 2 times A times C times the cosine of this angle, C, that's going to equal this side, C squared. Now it actually fits. If you look at it, it's kind of a part of the Pythagorean theorem. We can take this piece out. It just says A squared plus B squared equals C squared. That's because the cosine of 90 degrees is actually 0. So this would all cancel out if we were using a right triangle. Now we're not using right triangles all the time, so this cosine won't always come out to 0. So all of this does fit together though, and it works for any triangle ever. So let's see how to use that then. If we have this triangle, DEF, angle D right here is 60 degrees, and we have 6 inches and 7 inches on the sides. Now we need to find this missing side. Okay, again, here's the formula. We just plug in what we know. We'll call A this 6 inches, B this 7 inches. So 6 squared plus 7 squared minus 2 times 6 times 7 times the cosine of C, which is this angle now, 60, which means it's giving us this side across in the end. This is what we're solving for. Well, this side, there are no more variables. We can just solve everything out. 6 squared becomes 36, 7 squared becomes 49, 2 times 6 times 7 times the cosine of 60 becomes 42. So all of this equals C squared. Simplifying that down, we get 43 equals C squared. To get C alone, you have to take the square root of both sides. Now that square and that square root cancel out, so it's just C alone. So you can either leave it as C equals the square root of 43. It doesn't say here whether to leave it in simple radical form or round it to the nearest tenth, but this would be simplest radical form. It's still in a square root, we can't break it down. This would be rounding to the nearest tenth. This is the closest answer for that. So we would say this length is about 6.6 inches. Now we can do the same thing if we're finding an angle. This one is a little bit longer, takes a little more work, but you can still do everything. Because in the end, we'll be plugging in something for little a, little b, little a, little b, and little c, because we have all of the sides. So we can do that to find our last missing angle, x here. So since x is the angle we're looking for, we're going to consider that c, which means this one across from it has to be our c value, the 5.39. So when we plug everything in, we can mix and match these two, it doesn't really matter. We'll call this one A and this one B. This one has to be C though, because it goes with our big angle. So 7.6 squared plus 5 squared minus 2 times 7.6 times 5 times the cosine of x, I'm going to call it x now, that's the one we're looking for, equals 5.39 squared. Now again, I'm just going to simplify all of that down. This piece was here, this piece was here. 2 times 7.6 times 5 became 76, and it's still being multiplied by the cosine of x. And 5.39 squared became 29.0521. Now, to start balancing both sides, I can subtract these two, the 57.76 and minus this 25. I'm going to do that on both sides. So here and over here, minus, you can write in numbers, minus all those numbers. When we do that, the left side is now left with negative 76 times the square, or the cosine of x equals negative 53.7079. Now here we were using it as like a minus this amount. When it's all alone now, there's nothing out in front of it, you have to think of that as a negative 76 times all of this. So to get rid of it, we'd have to divide both sides by negative 76. Cancels and cancels. Divide by negative 76. Which means cosine of x is going to be this mess, 0.7066828 and more. There's more behind it. To get x all alone then, we do our cosine inverse on both sides. Cosine inverse of all of this. Those will cancel out. When we plug that into our calculator then, we'll get that x is going to be around 45 degrees. So we'll just round it to the nearest degree and call it 45. Now that we know that, we can, if we want, use that with our law of sines to find all the other ones, but they only asked us for the one, so we'll just leave it at that. We're going to save mixed examples for our next video, so we're going to call it quits on this one.